Yes. Yes. So, good afternoon, dear students.
Good afternoon, ma'am.
Yes, good afternoon. Okay. So, from today, here we are going to start with the preparation for KCT. Yes. So, exactly after a month, you have your CET exams, right? So, we are focusing here on the important MCQs. Okay, so we are going to solve some of the important MCQs. Okay, applied questions here, so which will help you for getting you good marks. Okay, so so similar questions are asked. Okay, so such questions we are going to solve here so that it will boost your confidence. Okay, for cracking the exam. Okay, for cracking your KCET exam. So today we are going to start. So from morning uh, you have attended the various classes. Okay, so biology, maths, and physics. So this is the last class. That is your chemistry class. Okay, so here I'm going to start with the first chapter. That is your solution chapter. And recently you might have completed your this right. So we have started with the second year portion first. Okay, so I've started with the first chapter from second year. That is your solution chapter. So let me start with the solutions. Okay, so in this chapter solution, so as you know, so this particular chapter solution is from physical chemistry. Okay, so from this what all are the important concepts? Okay, so here the questions are most probably asked on the concentration. Okay, expression of concentration, expressing the concentration in different methods. Okay, then you might have also discussed the various colligative properties, right? So colligative properties, so on the various colligative properties like elevation and boiling point, freezing point, depression, okay, osmosis. So so these are the important concept. Okay, from where you're going to get the questions. Then Henry's law, Rawls law. Okay, then the difference, the ideal solutions, non-ideal solutions. So these are the important concepts. Okay, from this we are going to, we have taken some of the important questions. So let's start. Okay. So this is the first question, that is, by increasing the temperature, the vapor pressure of a substance. Okay. So as you all know, okay, so what you can do for answering, okay, you can use your chat box. You can answer the answers, okay, in the chat box. So you might have gone through the synopsis which have been sent. Okay. So I'm not going to discuss the synopsis. So what you are going to do, so whatever you have understood, okay, based on that, you can answer in the chat box, or you can unmute yourself and also answer. Okay, but don't disturb the entire class. So, so you can just unmute for a okay, for 2 seconds. You can answer, and then you can uh, mute again. Okay, so this is the first question. By increasing the temperature, the vapor pressure of a substance. Okay, what happens to the vapor pressure of a substance? A, always increases. B, does not depend on temperature. C, always decreases. And D, partially depends on temperature. Okay, what is the answer, students? What will be the answer for this? By increasing the temperature, what will happen to the vapor pressure? Yes, what will happen to the vapor pressure? As you increase the temperature, vapor pressure. Okay, just a second. Okay, so what will happen to the vapor pressure, students, as you increase the temperature? Okay, Ranjita has answered it as A. Okay, good. What about others? Vapor pressure. So as you increase, okay, vapor pressure. So vapor pressure, okay, it is the pressure exerted by the vapors on the surface of the system. Okay. Now, so as you increase the temperature, what will happen to the rate of vapor? This also, yes. So it always increases. Okay. So as you increase, suppose I have taken a container. Okay, I have taken a container. In that container, I have a volatile solute. Okay, and I have a non-volatile solute and a volatile solvent. What will happen? So, and you cover the surface. Okay, and you increase the temperature. I supply the temperature from below. Now, what will happen? Whatever the non-volatile solute is there. Okay, so the solvent is there. That will what they will create the vapors on the surface. Okay, so as you increase the temperature, what will happen to the vapors? Okay, the vapor pressure of the substance also increases. Okay, it increases. So because why it increases? Because more vapors are produced at the surface. More vapors are produced. As you are increasing the temperature, what will happen? More vapors are produced, and thus the vapor pressure will be more. Okay, so the answer is what? What is the correct answer? The correct answer is A. Okay, good. So Shubham and Aranjita have answered. Good. Okay, so let's go for the next question. So this is the next question. So the vapor pressure of two liquids. So they have given two vapor pressures of two liquids. That is, two liquids are given, P and Q. Okay, P and Q are the two liquids, and their vapor pressures are given. So the vapor pressure of the P is 80 torr. Okay, and of that of the Q is 60 torr. Okay, is 60 torr. So the total vapor pressure of the solution. So the total vapor pressure of the solution is obtained by mixing. Okay, by mixing 3 moles of P. Okay, 3 moles of P and what? And 2 moles of Q would be. So what is the total vapor pressure? So they have asked what is the total vapor pressure if the number of moles, okay, of P is 3 and number of moles of Q is 2. So these are the options. A is 72 torr, B is 140 torr, C is 68 torr, and D is 20 torr. Yes. So what all is given? Okay. So for the first thing, what you have to do is what all things are given, that you have to note it. Okay. So what are the given things? So the vapor pressure of P is given. So vapor pressure of P is 80 torr. Then vapor pressure of Q is given. Okay. Vapor pressure of Q is what? 60 torr. Okay. 60 torr. Then what is the P total? How do you calculate the vapor pressure? Vapor pressure is what? How do you calculate? So vapor this vapor pressure can be calculated by the P into your number of moles, right? So P into the pressure, vapor pressure by created by P into your number of mole fraction of P plus vapor pressure of Q, okay, plus into Q, okay. So put the values now. So vapor pressure is 30. Okay, so vapor pressure is 80. Vapor pressure of P is what? 80 into the number of moles. How do you calculate the number of moles of okay, so number of moles can be calculated by what? Number of moles of P is what? It is number of moles of P divided by the total number of moles of P plus Q, right? So this is the formula. So how it is? So this will be P is what? It is 3, right? It is 3. So your 3 divided by what is the total number of moles of P plus Q is 5. So it is 3 by 5. Okay, plus then vapor pressure of liquid Q is how much? It is 60, right? It is 60. Then into mole fraction. What is the number of moles of Q can be calculated as number of moles of Q divided by the total number of moles by P plus Q. That is how much now again. So here it is, number of moles is 2 by 5. Okay, 3 plus 2. So it is 2 by 5. So calculate now. So I've told you, I've given you the substitution. So now you can tell me the answers. Yes, so after solving this, okay, so the P total, the total vapor pressure created by the two liquids P and Q. Okay, it will be, so after solving this comes to 48 and this comes to, just a second. So here, so fine. Do the substitution. Okay, anybody has answered? Okay, Shubham has answered it as A. Okay, others? So 16 into 30 plus. So 12 into 2. So after solving this, you get this as 48 plus 24. So it comes to 72 torr. Yes, good. Yes, good. Okay. So yes, Vedvati, Ranjita, then Shubham. Yes, good. Your answers are right. Good. Okay. So like this. So you are going to use this particular formula. Yes, Swati has also answered it right. Okay. So like this. So like this, the question is asked. Okay. So let us go for the, so similar pattern will be there. Only the numbers will be different. Okay. So the vapor pressures of any two liquids will be given. Okay. And they will ask you the total vapor pressure, how you have to calculate. So you have to use this formula. Okay. And use and apply it. Okay. Next. Okay. Next one. Let me clear this. Which is not a colligative property. Okay, which is not a colligative property. A, freezing point. B, lowering of vapor pressure. C, depression of freezing point. And D, elevation in boiling point. Yes, what is not a colligative property? So before that, what do you mean by colligative property, students? What do you mean by colligative property? So very important, as I've mentioned you before also. So colligative, as you know, for your theory, for your finals, or for your board exam also, right? The questions are mostly you get numericals, okay, on colligative property. So what are colligative properties? So colligative properties are the properties of the solutions, okay, which depends only on the number of solute particles, okay, and not on the nature of solute particles, okay, and thus These properties are called as what? Colligative properties, right? So what are colligative properties? So they depend upon the number of solute particles and not on the nature of solute particles. And these properties are called as colligative properties. So there are four important colligative properties, right? So first is the relative lowering of vapor pressure. Then is what? Relative lowering of vapor pressure. Then you have elevation in boiling point. Then you have depression in freezing point, and one more you have is your osmosis, right? So these are the four main colligative properties. Now here, which is not the colligative property? Yes. Okay, let me see the answers. Who all have answered? Okay, Swati has answered as A. Others? What about others? So which is not a colligative property? Yes. Okay, yes. So it is A. Yes, Ranjita have also answered. So let us take answer quickly. So it is A. Okay, your freezing point. So lowering of vapor pressure, depression of freezing point, and elevation. So these are all the colligative properties. So this colligative property, it is strictly applied for only dilute solutions. Okay, and they behave as ideal solutions. Okay. So there are different colligative properties: relative lowering of vapor pressure, okay, osmotic pressure, then elevation of boiling point, depression in freezing point. So answer A is not the correct answer. So A is not the colligative property. So let us go for the next question. Okay. A solution, okay, a solution containing 10 grams per dm cube of urea, okay, is isotonic with a 5% solution of a non-volatile solute. The molecular mass of this non-volatile solute is, okay. So what do you mean by isotonic solution? Quickly, what do you mean by isotonic solution? So the solution, two solutions having same osmotic pressure, they are called as what? They are said to be isotonic in nature. Now, for the solution to be isotonic, their osmotic pressure should be same. Okay. Now here, so there are two solutions given. Okay, two solutions given. Now osmotic pressure can be calculated as what? It is given as pi. Okay, pi is equals to CRT. Okay, pi is equals to CRT. Now your C is what? Concentration. Concentration is nothing but number of moles. Okay, number of moles divided by the volume. Okay, so number of moles divided by the volume, so that is equal to RT. So if I transfer this, so it will be pi V is equals to nRT. Okay. Then, so substitute, or you take it this only, because we want what all things are given. So this will be the formula. So pi is equals to CRT. What is concentration? Concentration is nothing but number of moles, okay, dissolved in per liter of solution, that is in volume. So in RT, R is your gas constant and T is your absolute temperature. Okay, so let us put into the formula. What are the number of moles? Number of moles is how much here? 10 grams. Okay, 10 grams per dm cube is the number of moles. That is 10 gram per dm cube of urea. Okay, and the molecular mass is given. So the 1 dm cube is nothing but 1 liter. Okay, remember that 1 dm cube is nothing but 1 liter of solution. Okay, now, so let us put these values first. What is the volume? Volume is what? 10 gram per dm cube of urea into the molecular mass of 60 gram per mole. Okay. So we are going to take 10 moles in volume. So it is dissolved in 60 gram. Okay. So it is 60 into, okay. Then what is R? What is the value of R? R is 0 0.0831. Okay. We are taking then into temperature, that is temperature we don't know, because so the molecular mass of this non-volatile solute is, so let us now 5%. Next is what? 5%. So 5% solution means what do you mean by 5%? 5% means 5 grams dissolved in 100 ml, right? 5 grams dissolved in 100 ml, right? So this is the pi 1. So this we have got for pi 1. Now we are finding it for non-volatile solute. So first was non-volatile solute. Okay, solute. Okay, so this is pi 2. So let us calculate for that. So 5 grams in 100 ml. Okay. Now, how much is given here? So we are calculating in terms of what? Liters, right? So we are calculating in terms of liter. So here we are not considering ml. So how much it will be? So 5% in 100 ml is for your ml. So we are converting into liters. So it will be 50 grams in 1000 ml. Okay, 50 grams in 1000 ml. So what is the number of this will be? Number of moles is 50. Okay. Then molecular mass, we don't know the molecular mass, so we'll keep it as M. We don't know. Then into, okay, into what? Into this is 0.0831 into temperature. So let us now relate this pi 1 and pi 2. So let us relate pi 1 and pi 2. So we know that for isotonic solution, pi 1 is equal to pi 2, right? So let us put this value. So 10 into, so simultaneously, you all also do. So 10 into what is the molecular weight is 60 into 0.0831 into T is equals to, so let me clear this below line. Okay. So is equals to, then pi 2, what is the pi 2? It is 50. So this particular 50, we don't know the molecular weight of the solute. So we have to find out the molecular mass of the solute into 0.0831 into T. Okay. Now what you are going to do? So just see. So T cancels, this cancels. Okay. Just relate it and just find out. So your molecular mass after calculating, okay, just substitute and you will get as what? What will be the answer? Just see after you solve this. See what answer you're getting. So come with the final answer. So I've given you the substitution. So just substitute and get me the answer. Okay. Aishu has answered it as A. Okay, good. Others? So 10 divided by 60. Okay, so this comes to 0.166 into 0.0831 into T, okay, is equals to 50 divided by into, so 0.0831 into T. So this after solving, okay, you will get as 300 gram per mole. So you have to get it as 300 gram per mole. Okay, are you getting the same? Just check. Everybody is getting the same. Yes. Okay. So shall we move for the next one? Is it clear? Is it clear? So osmotic pressure. Okay. What we have seen here? We have seen here the isotonic solution. So isotonic solution means what? They have same osmotic pressure. Same osmotic pressure means pi 1 is equals to pi 2. Okay. So we are relating it. So by this, we are going to find the molecular mass of the non-volatile solute and it comes to be A. That is 300 gram per mole. Okay. So let me go for the next question. Okay, so the next question is Van 't Hoff factor I for a compound which undergoes dissociation in one solvent and association in other solvent is respectively A less than 1 and greater than 1, B less than 1 and greater than 1, less than 1 and less than 1, then C greater than 1 and less than 1, and D greater than 1 and greater than 1. So what will be the Van 't Hoff factor? So we have, so you have also come across what is Van 't Hoff factor. Okay, the last part in the, so Van 't Hoff factor, it tells you what? It tells you the extent of dissociation and association. Okay. The Van 't Hoff factor, it tells you the tells you the extent of association and dissociation. Now, whenever you are studying the value of I, so remember that. Okay, remember this point. Value of I, okay, is greater. It is greater for what? It is greater than unity. It is greater than unity for dissociation. For dissociation. Okay, for dissociation, and it is less than 1 less than 1 for less than 1 for association. Okay, remember this, very important. So from Van 't Hoff factor, only this part is important. So what is the answer then? What will be the answer? 10th one. It is if the Van 't Hoff factor I for a compound which undergoes dissociation. Dissociation means it should be greater than 1, and for association it should be less than 1. So it is C. Okay, let me see. Yes, Shubham has answered. Vedvati have answered. Ranjita has answered. Bhuvan has answered. Jyoti, yes. And okay, good. Okay, yes. So everyone has answered it as C. Very good. Yes. So C is the correct answer. So, okay, one more answer. Shashank has also answered. Good. Okay, so this is about Van 't Hoff factor. So please remember this line. Okay, whatever I've written, just value of I in case of dissociation, it will be always greater than 1. And in case of association, it will be less than 1. Okay, so let us go for the next question. During osmosis, the flow of water through a semi-permeable membrane is. Yes, now we have also seen, okay, so what is osmosis? What is osmosis, dear students? Yes, what do you mean by osmosis? What happens during osmosis? So osmosis is what? It is a phenomena in which the flow of solvent molecules from the phenomena of flow of solvent molecules, right? From the solvent into the solution, or what happens? The dilute or from dilute solution into it undergoes into a concentrated solution, and through what? Through a membrane. Which membrane? It is a semi-permeable membrane. So what is the correct answer? A, from both sides of semi-permeable membrane. How is the flow of water? Yes, from both sides of the semi-permeable membrane with equal flow rates. B, from both sides of semi-permeable membrane with unequal flow rates. C, from solution having lower concentration only. And D, from solution having higher concentration only. Yes, what happens during osmosis? Just now I've told you. So this phenomena occurs okay, that is a flow of solvent molecules from solvent into the solution. That is from a lower concentration to a higher concentration through a semi-permeable membrane. So what is the answer? How is the flow of water? Water is what? Water is a solution. So how it flows? Yes. So it flows from what? It flows from a lower concentration to higher concentration. So what is the correct answer? The correct answer is C. Okay, C is the correct answer. So osmosis, it is a phenomena, okay, where we see the movement of solvent molecules from a concentration which is lower to a concentration which is higher. Okay, so it is C. So all the things which we have studied in the theory part, so that only we are applying. Okay, next one. Next question. Which one of the following salts will have the same value of Van 't Hoff factor as that of K4FeCN6? Hexacyanoferrate potassium. Yes. So which one of the following salts will have the same value of Van 't Hoff factor I as that of this particular complex? Okay, let us calculate. Okay. So K4Fe, K4FeCN6. Okay. Okay, Vedvati has answered it as A. So this K4FeCN6, okay, if it dissociates into 4K plus ion plus FeCN6 minus, right? So similarly, so you have to write for the others also. See, NaCl, if it dissociates into Na plus and Cl minus. Then Al2SO4 thrice, if it it will dissociate into what? 2Al plus 3 plus 3SO4 minus. Okay. Next. So now calculate. So here then Al NO3 price. So if this associates, so it will be Al plus 3. Okay. Plus 3 NO3 minus. Okay, then Na2SO4. If it dissociate, it will dissociate into 2Na plus SO4 minus. Okay, SO4 minus. So 2SO4 minus 2. Okay, now here, calculate the dissociation. So here, how you will calculate? So this is 2 plus 1. Okay, this will be 3. Now here, 4 plus 1. So in case of the main one, so how much it is? How many I value is what? I is 4 plus 1 is 5. Now here 1 plus 1 is 2. Okay, so this is wrong. This is also wrong. Then AL plus 3. So here it is 2 plus here it is 3. So this is 5. So this is 5. Then here this is 1. This is 3. So this is 4. So this is also wrong. So which is the correct answer? It is A. What is the correct answer? A. Yes, Aishu, Ranjita have answered it right. So it is A. So like this, we calculate the Van 't Hoff factor I. Okay, so how the Van 't Hoff factor I is same as that of K4, Fe, CN6. So we have to see the degree of dissociation. So after dissociation, how many ions are released? Okay, so calculate it and just add the and see the values. Okay, is it clear up to here? Yes. Any doubts up to here, dear students? Shall we proceed further? Okay, so let us go further. Next one. The osmotic pressures of equimolar solution of BaCl2, NaCl and sucrose will be in the order. Yes, so what is the osmotic pressure of the equimolar solution? So equimolar solutions of BaCl2, okay, then NaCl and sucrose. So what will be the order of this osmotic pressure of these solutions? Yes, just see the series. A, sucrose is greater than NaCl and BaCl2. B, sucrose is greater than BaCl2 and NaCl. C, NaCl is greater than BaCl2, which is greater than sucrose. And D, BaCl2 is greater than NaCl, which is greater than sucrose. Okay, Jyoti have answered it as D. Others? So when you have to see the number of moles, okay, number of mole particles in BaCl2, NaCl and sucrose. What is the number of mole particles? Calculate the number of mole particles. So in, okay, so this is what? This is an ionic solution, okay, non-electrolyte. So this is a electrolyte. So here, when BaCl2, when it dissociates, it will dissociate into Ba plus 2 and 2Cl minus. So it will be BaCl2 will dissociate into Ba plus 2 and 2Cl minus. Okay, so this is 1 plus 2. So it is 3. Then NaCl will dissociate into Na plus and Cl minus. So it is 1 plus 1. Okay, so it is 2. And sucrose, okay, it is a so it is not this, so it is a non-electrolyte. Okay, so this we'll calculate it as 1. We take it as 1. So what is the number of mole particles? So it will be 3, 2, and this is 1. So which is greater? So 3. So when we see the osmotic pressure, so BaCl2 will be greater than NaCl, which is greater than sucrose. So it is option number D. Okay, option number D. D is the correct answer. Okay, so let me see who have answered it. Okay, Jyoti. No. Okay, so the answer is option number D. Okay, option number D. Okay, so Vedvati have answered it. So option number D is the correct answer. So we have to see the degree of dissociation. We have to calculate the number of moles. We have to calculate the number of moles. So depending on the number of moles, how we have arranged it in the order of increasing order. Okay, so the osmotic pressure of equimolar solution will be in this order. That is D option. Okay, let us go for the next question. Which of the following aqueous solution has minimum freezing point? Okay, how do you calculate the freezing point? So which of the following aqueous solution has the minimum freezing point? So depression in freezing point, it can be calculated by which formula? It is delta TF is equals to I into KF into M. Okay, so the four options given are A, 0.01 molar NaCl, B, 0.005 molar C2H5OH, C 0.005 molar MgI2, and D 0.005 molar MgSO4. So this is the formula for calculating the depression in freezing point. So which is given as delta TF is equals to I into KF into M. Okay, so Ventov factor I so if you calculate the Ventov factor for I for NaCl, what is NaCl? It will be 2, right? Because NaCl, if it dissociate, it will dissociate into Na plus and Cl minus. So you know now. So I is equals to 2. Therefore, what will be the, if you put this value, okay, of delta TF, so delta TF will be what? It will be I is 2 into molality is 0.01 into Kf. So if you calculate, the answer comes to 0.02 Kf. Okay, so this is the first answer. So let us calculate the others. So same way you calculate for others also. So delta TF is equals to for C2H5OH and for MgI2. Okay, so if you calculate for others also, so MgSO4, Mg plus 2 plus SO4 minus 2. So here also the Van't factor is 2. Then C2H5OH, so the Van't factor is 1. And MgI2, okay, so Mg plus 2 and 2I minus. So this is 3. So put the values. I use this formula and calculate. Yes, students. See. So so see here, if the maximum, how much value will come? Okay. Now delta TF. So when you calculate the delta TF, so delta TF will be maximum. Okay. So delta TF should be maximum. Then the freezing point will be minimum. Okay. So Jyoti has got it as A. Yes. Others, C, put the values. So similarly, how I have solved for NaCl, same way you have to put the values of I and get the values of delta TF and see which is having the minimum freezing point. Okay, so minimum freezing point. So if the so delta TF will be maximum. Okay, so KF value will be maximum. So if delta, so whichever delta TF value is maximum. So if this is maximum, then the what is that? Freezing point will be minimum. Okay, so this value should be maximum. So you can see that this is 0.01 and rest all are 0.005. So the values here, the delta TF value will be less, okay, as compared to this one. So this will be more. So if the delta TF value is maximum, then your freezing point will be minimum. So our answer is A. Okay, our answer is A. Are you getting it? Yes, are you getting it? So whenever we are calculating the minimum freezing point, so we are going to use the delta TF. So we are calculating the delta TF. So if delta TF, the value is maximum. So if the value is maximum, means it is having minimum freezing point. The freezing point is minimum. Okay. So the answer is A. So put the values and you can also see the answer. Okay, what you're getting. Okay, let me go for the next one. Camphor. Camphor is often used in molecular mass determination because camphor. So why we are using camphor in molecular mass determination? A, it is readily available. B, it has a very high chiroscopic constant. C, it is volatile. And D, it is a solvent for organic substances. Camphor, kapur. Okay. Why we use that camphor? Why we use camphor in molecular mass determination, students? Because, okay, Jyoti has answered it as D. Okay. Okay. So, what do you mean by this chiroscopic values, students? What do you mean by this chiroscopic values? Chiroscopic substance. So it tells you what? It tells you about, it relates you about the freezing point. Okay. Yes, the Kf value. Good. Okay. So it depends on what? The camphor is oftenly used in molecular mass determination because it has a very high chiroscopic value, because solvent, okay, the solvent is having the very high chiroscopic value, and this can be used in determination of molecular mass. Okay. So because it is having a high Kf value. So remember this. So option number B. So let us go for the next one. In a mixture, A and B components show negative deviation. Okay, you have a mixture of A and B components. So A and B components are there and they are showing negative deviation. So negative deviation means A, delta V mix is greater than 0. B, delta H mix is less than 0. C, AA-AB interaction is weaker than AA and BB interaction. D, AB interaction is stronger than AA and BB interaction. So if you have a mixture of A and B, okay, and it is showing a negative interaction, what it means? Yes, what it means? So it means that your, okay, I have got some answers. Jyoti and Shubham have answered it as B. Okay, they have answered it as B. Okay, so for negative interactions, okay, for negative interactions, what will happen? Yes. So for negative interaction, okay, Ranjita have also answered it as, see here, for whenever you have a negative interactions, okay, for negative interactions, okay, you know that delta H mix is not equal to 0. It is not equal to 0. Okay, it is not equal to 0. Now, either it should be greater than 0 or it should be less than 0. Now, here, when we are talking about the interactions, okay, when we are taking about the interactions, so when we are considering the interactions, your the AA interactions and BB interactions, okay, they are weaker. Okay, they are weaker than that of AB interactions. So that time what will happen? That time your delta H will be negative. Okay, it will be negative, or as well as your delta V mix also will be negative. So your option is D. Option is D. So your AA and BB interactions are weaker when we are studying the negative deviations. When we are studying the negative deviations, you can see that your AA and BB interactions are weaker than that of the AB interactions. Solute-solvent interactions is okay, it is stronger, okay, as compared to your solute-solute and solvent-solvent interactions. So that time your delta H, that is the change in enthalpy, will be negative, and your delta change in mixing, okay, that is a change in mixing will be also, volume mixing will be equal, is negative. So this is with respect to your negative deviation. So option number D. Okay. Next question. Which of the following liquid pairs shows a positive deviation from Raoult's law? So when you are studying the deviations, okay, so there are some examples which are listed out. So please go through the examples, very important. So like this, the questions are given. So they will give you, okay. So some options will be given, pairs will be given. From that, you have to choose the correct and you have to tell which of the pair is showing here the positive deviation. A, water nitric acid. B, benzene methanol. C, water hydrochloric acid. And D, acetone chloroform. Okay, Vedvati has answered it as A. Others? Okay. Ranjita has answered it as B. Jyoti has answered it as A. Okay. Okay. Now positive interactions are shown by what? Positive interactions. Positive interactions are shown by what? Positive deviation is nothing but your what? They are shown by the solutions where your solvent-solvent interactions and your solute-solute interactions are stronger. Okay, are stronger, right? Are stronger than your solvent interaction. So solute solvent and this is interaction is stronger. So when we are comparing your AA interactions and BB interactions, in case of your positive deviation, they are stronger than your AB interactions. They are stronger than what? Then they are stronger than your AB interactions. Okay. In such solution, what will happen? The interactions, okay, the interactions between the molecules will become weaker. Okay, they'll become weaker in solutions. When you are comparing the solutions, okay, when you take the solution, the interaction will become weaker. So what will happen? Thus, the tendency, okay, of escaping will increase, okay, and there will be partial vapor pressure increases. Slowly, the partial vapor pressure increases. So in such solutions like your benzene and methanol, okay, if you have a benzene and methanol in such system, there will exist what? There will exist your hydrogen bonding. Okay. So benzene, what will happen? The benzene molecules will come between the ethanol. Okay. And thus they will weaken your forces. So thus they will be resulting in the vapor pressure. So the answer is B, benzene and methanol. Okay. So answer is benzene and methanol. So option number B is the correct answer. Okay. Ranjita have answered it right. Okay. So let us go for the next question. The molecular weight of benzoic acid in benzene, okay, as determined by depression in freezing point method corresponds to A, ionization of benzoic acid, B, dimerization of benzoic acid, C, trimerization of benzoic acid, and D, solvation of benzoic acid. What is the molecular weight of benzoic acid is benzene as determined by depression of freezing point? Yes, the molecular weight of benzoic acid in benzene. The molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to ionization of benzoic acid, dimerization of benzoic acid, trimerization of benzoic acid, solvation of benzoic acid. Okay. Okay, good. Okay, so the answer is yes. Jyoti and Ranjita have answered it right. So the molecular weight of benzoic acid in benzene. Okay, so when we are determining the benzoic acid, okay, when we are determining the benzoic acid, hmm, the molecular weight of benzoic acid. So what it will undergo? So benzoic acid is what? So this is your benzoic acid. Okay. So by determining the depression in freezing point, so it corresponds into dimerization. It undergoes what? It undergoes dimerization of benzoic acid. So option number B. Option number B. Okay. So benzoic acid, it will exhibit as what? It will exhibit as dimer. Okay. It will exhibit as dimer. What do you mean by dimer, students? Dimer, dimer. Yes, it will associate. It will associate with each other. Okay, it will associate with each other. So each benzene. So like this. For suppose I'll show you how it will be, how it undergoes dissociation. So C double bond O. Okay, then your O, then here COOH. Okay, so your O, so it will undergo like this dimerization. Okay, okay, so like this, the dimerization is formed. So C double bond OH and C double bond OH. So like this. So this is the uh, dimer formation. So this is a dimer formation. Okay, let me write it properly here. Okay, so like this. So the benzene, what will happen here? You can see that the benzene is forming what here? So it is undergoing the what dimerization. So like this, the molecular weight, okay, it corresponds like this. So it is B. It will undergo a dimer formation. Okay, let us go for the next one. If A contains 2% NaCl and is separated by a semi-permeable membrane from B, which contains 10% NaCl, then which event will occur? A, NaCl will flow from A to B. B, NaCl will flow from B to A. C, water will net flow from A to B. And D, water will net flow from B to A. Yes, what will happen? So we have two containers. Okay, in one container, we have a solution A, which consists of 2% NaCl. And in another container, we have a solution B, which is having 10% NaCl. Okay, and it is separated by a semi-permeable membrane. Okay, now how the flow is possible? From A will move, the flow will be from A to B or B to A, or water will net flow from A to B, or water will net flow from B to A. Yes. What is osmosis? So this is a concept of osmosis. So osmosis is what? The flow of solvent molecules from the concentration, low concentration to the high concentration. So which is the answer? The water molecules, AC. Okay, so the solvent molecules will flow. That is the water molecules. Okay, it will flow from low concentration to high concentration. Okay, so it is option number C. Okay, yes, Ranjita have answered it. Good. Okay, so let us go for the next question. A solution of urea, okay, whose molecular mass is given as 56 grams per mole. It boils at 100.18 degrees Celsius at the atmospheric pressure. Okay, if Kf and Kb for water are 1.86 and 0.512 Kelvin kilograms per mole, respectively, the above solution will freeze at A 0.654 degrees Celsius, B minus 0.654 degrees Celsius, C 6.54 degrees Celsius, and D minus 6.54 degrees Celsius. Okay, so how to solve this? Yes. So delta TF is given. Okay, delta TF has to be calculated, and TB. Okay, so that is both. So delta TF, as we know, delta TF is what? KF into M, and delta TB is what? KB into M. Okay, so we know that molarity is equals to delta TF upon KF is equals to delta TB into KB. Okay, or delta TF is equals to delta TB into KF by KB. Okay, so now put the values. So what is delta TB? How do you calculate change in this? So boiling point, so higher the boiling point is 100.18 minus 100 degree. This will be 0.18 degrees Celsius. Okay. Now, next is, so put the values. So delta TF is what? Now put the values. Now your molecular mass of this is given as 56. Now what you want is delta TF. So delta TF, KF and KB values are given. KB and TF value. Let me write it. So KF value is what? It is 1.86 and KB value is 0.512. Okay. So what is delta TF? So delta TF is, So delta TF is equals to, so we are calculating the delta TF. So delta TB we have calculated. So delta TB is 0.18, okay, into KF. What is KF? Put the value of KF, where it went, 1.86 divided by KB is 0.512. Okay, see how much you're getting? How much you're getting? Ranjita has answered it as B. Okay. Others? So what the value you are getting? So after solving this, you have to get it as 0.654 degrees Celsius. Okay. So this is delta TF. This is delta TF. Now we have to freezing point of the pure water. So we know that the freezing point of pure water is 0 degrees Celsius. So delta TF is equals to 0 minus TF. So what is delta TF? We got it as 0.654, okay, is equals to 0 minus TF. So just see that. So therefore TF is equals to minus 0.654. So what will be the freezing point? So the freezing point of the solution will be minus 0.654. Yes, option number B. Okay, let me see who all have answered it right. Bhuvan, Aishu, Tasmia, Ranjita, yes. So option number B. Okay, option number B is the correct answer. Okay, so like this systematically you have to relate the given equations and then substitute and then get your answer. Okay, so is it clear up to here? Okay, so let me go for the next question. Osmotic pressure of a sugar solution at 24 degrees Celsius is 2.5 atmosphere. The concentration of the solution in gram mole per liter is A 10.25, B 1.025, C 102.5 and D 0.1025. So osmotic pressure, okay, of a sugar solution. Sugar solution osmotic pressure is given at 24 degrees Celsius is 2.5 atmospheric pressure. Now what is pi? Pi is equals to CRT. Okay, what we have to calculate? We have to calculate the concentration. So concentration is equals to pi upon RT. Okay, what is pi? Pi value is 2.5 atmosphere. Okay, R is what? R is 0.082 into what is the temperature at 24 degrees Celsius. So it is 273 plus 24. Okay, so it will be 4, 5, 6, 7, 7, 8, 9, and 2. So it will be 297. Okay, so see what is the concentration? Okay, Ranjita has answered it as D. Others? See what answer you're getting. So after solving this, so 0.082 into 297, this comes to 24.354, 2.5. So now divide 2.5 divided by 24.354. So this comes to 0.1026. Everybody is getting the same. It is option number D. Yes, Bhuvan Jyoti. Yes, option number D is the correct answer. Yes, everybody else has got the same. Okay, so let us go for the next question. Okay. The freezing point of a solution prepared from 1.25 grams of a non-electrolyte and 20 grams of water is 271.94 Kelvin. If Kf is 1.86 Kelvin per mole, then the molar mass of the solute will be nearly. Okay, so what is given? So what all are given things that will write? So weight of the solute is given. Okay, weight of the solute or the non-electrolyte. Okay, it is given as what? 1.25 grams. Okay. Then weight of the solvent. Okay, what is the solvent? Water molecule. So weight of the solvent is given. So water or weight of the solvent, that is water, is what? It is 20 grams. Okay. Then freezing point is given. Freezing point of the solution. that is a temperature, freezing point, temperature, freezing point of solution. Okay, is given as what? That is temperature is 271.94 Kelvin. Then molar depression constant is given. Molar depression constant is 1.86 Kelvin per mole. Okay. Now we know how to calculate the this what molar mass of the solute in depression and freezing point. Okay, so that is M is equals to 1000 into Kf into W divided by what? Divided by delta TF. Okay, delta TF mine into capital W. That is the weight of the solute. So 1000 into Kf is what? Kf is 1.86. Weight of the solute is 1.25. Then delta TF is T naught minus T. What is T naught minus T is 273 minus 271.94. Okay. Into W is weight of the this is 20. Okay. So to solve this, see what answer you're getting. See what answer you're getting. Okay, Ranjita has got it as A. Others? So after solving this, systematically solve it and see what answer you're getting. Okay, Jyoti has also got it as A. So the answer you are getting is 109.67. Okay, I'll get this answer. So it is option number A. Okay, Vedvati has also got it A. Okay, so this is the correct answer. Is it clear? Yes? Okay. So these were some of the questions, okay, which we have solved today. So any doubts up to here? Any doubts you have up to here? So tomorrow also we are going to continue with the solution chapter, okay? So the remaining questions we'll be discussing in the next class. So if you have any doubts regarding today's session, you can ask me now. Okay. Others, any doubts, dear students? So the same topic solutions we are going to continue in the tomorrow's class. Okay. So any doubts you have? Okay. Thank you, Bhuvan. Thank you, Jyoti. Yes. Okay, fine. So we shall meet in the next class. Thank you. I'll end the session here.